Hi, this is Serge Panev from the NVIDIA's Deep Learning Frameworks engineering team, and I will present the GPU dependency rework in the MXNet engine. So the existing dependency engine efficiently tracks the dependency of variables between the operators. However, due to the synchronous nature of the GPU ops, the engine needs to ensure that all the kernels were fully executed before marking the resulting variables ready. This leads to a host device synchronization at the end of each op, blocking the CPU thread. As you may have guessed, this is suboptimal, as it prevents the host thread to run the next operators. Actually, we need to sync only when the variables are required by another operator or by the user. We leveraged CUDA events to have a better system and rely on the CUDA driver for the dependency between GPU variables. And also, I would like to add that this is an original idea from Przemek Trendák, who is also a co-author of the change. Okay, but what's the change? So here you have an illustration of what happened before. On the left, you have the execution flow of a single GPU worker thread. And as you can see, there are like three steps. So the setup, the op function itself, which for the GPU op will be mainly scheduling kernels, and at the end, the CPU blocking sync to make sure that all the variables are ready. So as you can see, for each GPU op, there will be one sync. And after, two things changed. First, there is no more host device sync at the end of the GPU op, but the engine will now record the stream into an event, which will be later used by the next ops to either stream wait event or by the CPU ops to make the actual host device synchronization, which is needed by the CPU op. And as we can see, in the full GPU op path, there are no more host device synchronization. In that way, we offloaded the GPU data dependency to the CUDA driver. How does it look like on the profile? Here you can see ResNet 50 running on a system with a single A100. Two issues. First, the engine worker thread is often blocked with CUDA stream synchronize and hence not able to schedule the next ops. The engine worker thread is often stalled with CUDA stream synchronize and in that way not able to schedule the next ops, which results into gaps in the stream, which results in a non-optimal pipeline of the GPU and CPU operations. After the rework, we can directly observe a better overlapping of GPU and CPU operations. The gaps disappeared in the GPU stream profile, and all the CUDA launches happen almost sequentially. There are no more sync after each kernel launches, because the CUDA driver takes care of the data dependency. The only visible sync in this profile is a huge CUDA event synchronize, which means that some GPU data needs to be accessed by the CPU. That's exactly what we want. And we get an optimal pipelining of the CUDA kernels. The GPU is busy, and the host device synchronization occurs only when switching to the CPU ops. And to conclude, let's take a look at some of the early results. On the left, there is a computer vision training example with ResNet 50, where the new engine gives a 9% improvement. And on the right, we can see an NLP example, where the Sokai inference is 6.3% faster with the new engine. And to end this short presentation, the details can be found, of course, in the PR, which is open on GitHub, but also in the description of the PR, which details the different components of the change. Thank you for listening.